All right, let's get right into it. We're going deep inside the modern semiconductor fab today to talk about something that's changing the game for every lithography engineer out there: artificial intelligence. And look, this isn't some far-off futuristic idea. This is what's happening on the ground right now.
I mean, really think about that question. It's what every lithography engineer is up against every single day. You're working at a scale that's just mind-bendingly small. We're talking about printing circuits with features tinier than a virus. At that level, all the normal rules of physics start to get weird, and the complexity is just off the charts.
And this number? $200 million. That's what a single top-of-the-line EUV lithography machine costs. Just one. So when a piece of gear costs more than a Hollywood blockbuster, you can bet that any downtime isn't just a little problem. It's a flat-out catastrophe that costs millions of dollars a day. The stakes are just incredibly high.
So, here's the real challenge we're facing. As we push down to 3-nanometer chips and beyond, these machines are creating a tidal wave of data. We're talking terabytes of sensor readings, logs, and performance metrics from just one trip through the machine. There is no way a human being or even a team of engineers can sift through all that noise to find the one tiny signal that actually matters. We've hit a wall.
And that brings us to this critical point. The industry has finally realized, to handle this insane level of complexity, to keep Moore's Law chugging along, AI isn't just a cool feature anymore. For a lithography engineer trying to keep things under control and do their job, it's become an absolute non-negotiable necessity.
Okay, so we've laid out the problem. Now, let's talk about the solution. And when we say AI, it's not some magic black box you just turn on. It's really a toolkit, a set of specific tools that help an engineer turn that flood of raw data into intelligence they can actually use on the fab floor.
First up in the toolkit is predictive maintenance. For decades, the model was simple. Either wait for something to break and then scramble to fix it, or do maintenance on a fixed schedule, whether it needed it or not. AI flips that entire script. It's constantly watching thousands of signals, temperature, pressure, vibration, to see the future, to predict that a part is about to fail so you can fix it before it ever brings the line down.
Next, we have the digital twin. I want you to picture a perfect one-to-one virtual copy of that $200 million EUV machine living inside a computer. Now you can throw anything you want at it. Test a risky new software patch, try out a crazy new process recipe, train a new engineer, all without ever touching the real thing. It's the ultimate virtual sandbox for getting work done without the risk.
And then there's a really cool technique called RAG. Think of it this way. A general AI knows a lot about everything, but a RAG-powered AI knows everything about your specific machine. It can instantly read every technical manual, every past maintenance log, and look at all the live data coming off the sensors to give you an answer to a troubleshooting question that's super accurate and totally relevant to your exact situation.
So, if we take this toolkit, we can start to build out what we're calling an AI Masterplan for the lithography engineer, and it's all built around 3 core missions that tackle the biggest headaches they face every day. Okay, mission number 1. This is the big one. It's an all-out war on unexpected downtime. Because in a fab, every single minute that a machine isn't running, you're not making chips. And the money you're losing just piles up at a terrifying rate. This is enemy number 1.
And the impact here is just staggering. When fabs put AI to work with predictive models and round-the-clock anomaly detection, the results are huge. We're seeing unexpected downtime cut by as much as half, maintenance costs dropping by 10 to 25%, and overall machine availability jumping by 15%. These are not small tweaks. This is a total transformation.
Mission 2 is all about one thing: getting more good chips out of every single wafer. The name of the game is maximizing yield. It's pretty simple, right? Every single defect, every chip that doesn't meet spec is literally just money thrown right down the drain.
And here's why that matters so much. Yield loss can be responsible for 20, even 30% of your total production costs. I mean, think about that. For every $4 you spend, $1 could just be vanishing into thin air. But by using AI to see the whole picture, to connect what's happening in lithography to what's happening in etch and deposition, you can start to seriously shrink that loss. That goes straight to the bottom line.
This quote right here really nails the shift in thinking. For so long, quality control was like detective work, finding the defects after the crime was already committed. The new AI approach is more like preventative medicine. It's about seeing that a process is about to drift off course and fixing it before it even makes a single bad chip.
And that brings us to our third mission. This one is all about the future. It's about using AI to help engineers move faster, to develop the next generation of chips more efficiently than we ever thought possible.
And this is where that digital twin idea comes back in a huge way. Instead of tying up a multi-million-dollar machine for months just to try one new idea, you can run thousands of tests on its virtual copy. But here's the real kicker. It's not just about cutting R&D time by 20 or 30%. It's about freeing up your most valuable resource, your engineer's brain power, from tedious busy work so they can focus on actual game-changing innovation.
AI is also making these insanely complex systems just easier to use for everyone. Can you imagine just telling a machine what to do in plain English? Or having an AI copilot that helps you write a new process recipe? This is happening, and it's making the technology more accessible, cutting the training time for new people by as much as half.
So now let's zoom out a little bit, because what we're talking about isn't just a simple upgrade for the factory floor. This move to AI is a massive fundamental shift in strategy for the entire semiconductor industry.
The way companies compete is totally different now. For decades, the goal was just to build a better machine, more precise, faster hardware. But today, the real competitive advantage, the thing that protects your business, is creating intelligent systems. The value isn't just in the metal anymore. It's in the software and the AI that makes the metal smarter.
This forces a really tough decision on every fab. Do we try to build all this AI stuff ourselves, or do we partner up? And, well, the data speaks for itself. More than 80% of internal AI projects at big companies just fail. The truth is, the equipment makers, the ASMLs and KLAs of the world, have a huge head start. They have decades of experience and, most importantly, they have the data from thousands of machines all over the world that you need to train really good AI.
So where does this all lead? What's the ultimate goal here with AI and the fab? Well, the long-term vision, the end game, is the rise of the truly autonomous factory.
We're talking about a factory that pretty much runs itself, a system where AI is constantly watching everything, learning from what it sees, and making tiny adjustments in real time to squeeze out every last drop of performance and yield with very little human oversight needed. And when that happens, you create this incredibly powerful feedback loop. Think about it. This smarter AI in our fabs helps us build more powerful AI chips. And those new, more powerful chips, well, they allow us to create even smarter AI to run the fabs of tomorrow. It's a cycle that's just going to accelerate and accelerate. Which brings us to the last and maybe most important question. It's for every engineer watching this right now. As these factories get smarter and more autonomous, what does your job look like? And the answer isn't about being replaced, it's about evolving. It's a shift away from being a hands-on operator to becoming a strategic thinker, an innovator, and a teacher for these incredibly powerful AI systems. Thanks for tuning in.